Hello everyone. Welcome to an early morning special version of Math with Audrey. Yeah, today is a very interesting day. So I just said, screw it. I'm going to come on live before I officially lose my mind. So this is why I'm here. Hey, Pops. Thank you for joining in. So today I'm going to possibly come on live twice. So I'm going to come on obviously now. And then later on I will be on roughly probably like around 7, maybe even earlier. Not too sure. Today is just one of those days, like if I'm not productive, something terrible is going to happen. So we don't want anything terrible to happen. So here we go. All right, so we are working on what's called combinations and permutations. So this is usually something that's seen in statistics or possibly probability. And I know some of the students are on spring break right now. I know they are for Maryland, but there are some other people that are not. They already had their spring break. So I want to break down a little bit of what is a factorial before we go into everything. Now, because this is going to be essential. So let me see if I can at least zoom in just a hair more. All right, so factorials. If you notice on tests or exams, if you see a number with an exclamation sign. There we go. Okay. And you're probably like, what the heck is that for? Okay. That is called a factorial. So it's a math operation where you multiply the number and all its descending positive integers. So if I take a look at 5 factorial, let me zoom in. Okay, so 5 factorial, that means I'm starting with my number of 5. And I'm going to multiply the rest of the numbers in descending order. So the next number will be 4, then 3, then 2, then 1. That's what the 5 factorial means. You're going to start at the 5 and you're going to be multiplying the descending numbers, the descending positive numbers, okay, the positive integers. So it's never going to be like fractions or decimals or anything you have to go in between 5 and 4. It's just simply 5, 4, 3, 2, and 1. So if you look at it this way, you got 5 times 4, that gives me 20. And since this is all multiplication, you can kind of group your numbers. So 5 times 4 will give me 20, 3 times 2 times 1 will give me 6, 20 times 6, that will give me a total of 120. Okay, hola. All right, same with the 8 factorial. So that means we're doing 8 times 7 times 6 times 5 times 4 times 3. I feel like I'm in a Janet Jackson video. 2, 1. Okay. 5, 4, 3, 2, 1. Bam. Okay. So you're probably like, man, I got to really put all that in a calculator. Yeah, you do. Yeah, you do. So you can do 8, 7, 6, 5, 4, 3, 2, 1. Hit your enter and you will get, let me see if I can slide this up. Actually, I'm going to have to do it like this because it's in my way. So we have a total of 40,320. So, but just like anything else in life, there is a shortcut to this. If you do have a TI-83, okay, not so much Desmos, but I think Desmos should have it. So if I wanted to do the 8 factorial, I will type in my 8. Then I will go to my math button, okay, which is just underneath your alpha. And then I will go over to where it says prob. Prob is short for probability. So I kind of have all these directions, whoop, right here. Okay, let me unzoom so you can see what's happening. So then I'm going to hit the left arrow because that will get me to the prob so much quicker. And then you notice at number 4, there's your factorial. And then hit enter, and boom, there's your answer. Okay? So again, if you just want to get to the factorial, you type in the number first, then you hit math, then you hit your left arrow so you can get to your probability section. I know it's PRB, did a little extra, I don't know why. And then you hit number 4. And then once you hit enter, you'll get to your factorial so much quicker. So instead of just doing 8, but if you don't have it, this is what you have to do. If there's an 8 factorial, you have to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that's how you do your factorials. All right, let me take this away for a second. Screenshot if you got to. Now, the next one is going to be 7 factorial times 4 factorial. Okay, 7 factorial times 4 factorial. So that means you're taking 7 factorial, so that'll be 7, 6, 5, 4, 3, 2, 1. And you're going to times it by the 4 factorial, which is 4, 3, 2, 1. So obviously, it's going to be a nice huge number. So let's use our skill a little bit. So if I have my 7, I hit my math, I hit my left arrow, I go to number 4 for the 7 factorial, hit enter. Then since I'm here, I'm going to do 4, hit my math, left arrow, number 4 for that factorial. Okay, so that means at the 7 factorial, I have 5,040. At the 4 factorial, I have 24. So I'm going to multiply those two together. Oops. And then I get my answer, slide over, of 120,960. Okay. All right. Christopher, thank you for the love. Thank you, Christopher. He's like, tap away. This woman is helping you out. Not asking for much in return. Well, actually, I am asking for a little bit. I want you to be great at math. Don't say that you suck at math and keep going on your life. You can definitely solve. You can definitely do this stuff. Okay? Now, another one is 0 factorial. Now, just like if I said anything raised to the 0 power, our answer should be 1. Okay? Just like with exponents, anything raised to the 0 power is 1. So 0 factorial, notice that all the factorials end in 1. Okay? So if I did the 7 factorial, the 7, 6, 5, 4, 3, 2, 1 is the last one. The 4 factorial, 4, 3, 2, 1, it never has a 0. It never has a 0. So if I have the 0 factorial, that means I just end in 1. Okay? Let me start squaring off my answers here so you guys get a good idea. Okay? So 0 factorial is not 0. It is 1. Thank you, Christopher. I appreciate you. Okay? It is 1. So now, sometimes you might see a problem because we did multiplication. We just did the individual factorials. Now we're going to do division. So if I said 10 factorial over 5 factorial. So let's think of it. Let me extend it out so you can really see what I'm talking about. So 10 factorial, so that'll be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, times 1. And the 5 factorial is 5, 4, 3, 2, 1. Okay? By looking at this, something's happening. 5 factorial is a part of the 10 factorial. Basically, from right here. This is the same as this. And when you have a number divide by itself, that equals 1. So basically, these two can cancel out. So all that you're left with is your 10 times 9 times 8 times 7 times 6. Because these two, the 5 factorial and the remaining part of the 10 factorial, are exactly the same. So since they're exactly the same, you can divide it out, which will give you 1. So now all you have to do is 10 times 9 times 8 times 7 times 6. And that will give you a total of 30,240. Okay. So if you have any questions, please put in the chat. Continue to tap. That'll be amazing. Okay. If you know someone else that, even if they're on spring break, and I know there's a few teachers, because I have a few students today, that gave them packets for over spring break. You gotta love it. I know I'm loving it because now I got clients. But, it's out there. You gotta love that. All right. So taking a look at this, if you really want to be able to break it down, you can do that. Okay. So same thing. Let me try one more time. Let me switch pens so it doesn't just blend in with the background. So if I said 45 factorial, you're like, oh God, Audrey. No, it's okay. And 42 factorial, I don't want you to just divide 45 and 42. No. Let's think of it. 45 or 42 factorial is within 45. So that means all I really need to do is start with my 45 times my 44, because we're descending, times my 43. But do I have to include the 42? Okay. Do I have to include the 42? So what is a factorial? It's a math operation where you multiply the number and it's descending numbers of positive integers. So it's basically like a shortcut. Okay. So instead of me representing all the numbers from 45 all the way to 1, I use that factorial symbol. Okay. So since 42 factorial is within it, they cancel each other out. So all I have to do is just focus on what is 45 times 44 times 43, and that will give me a total of 85,140. So this is basically how you're doing the operations. The division is the one that kind of takes it on. Okay. All right. So instead of you writing it all out, okay, whatever's in the denominator, that's where you can stop for the numbers in the numerator. So let's say for this one, when I had 10 factorial over 5 factorial, I could have stopped at the 6. Because the 5 factorials will cancel out. Because 5 factorial is a part of the 10 factorial. Okay. All right. One more problem. All right. So we have our 20 factorial over 15 factorial times 6 factorial. You're like, ooh, that seems fun. So if they don't cancel out, that means you are basically, well, it would, if it's division, it will cancel out. But just saying for giggles, that means you would have to multiply 45 all the way down to 1, and then 42 all the way down to 1, and then see what you can cancel out. You're always going to be able to cancel something out. Your denominator is never going to be larger than your numerator. And if it is, that means it's going to be 1 over whatever's left as a denominator. Okay? All right. So now we have 20 factorial over 15 factorial times 6 factorial. Now, like I mentioned, my denominator can cancel out with part of the numerator when it comes to factorials. So if I wanted to, I can say my 20 times my 19 times my 18, 17, 16, and kind of like have 15 factorial, because I know from here it's going to be 15, 14, 13, 12, blah, 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 right? Over my 15 factorial times 6 factorial. The reason why I'm writing it like this is because right away I can see that the 15 factorial are both going to cancel out. Okay, so instead of me keep going with the 15 times 14 times 13 times 12, blah, 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 all the way to 1, I can stop here at the 15 factorial. And these two can cancel out. Now what is left is what's happening in the denominator. So we have like our 20 times 19 times 18 times 17 times 16 over 6 times 5 times 4 times 3 times 2 times 1, because that is what 6 factorial is. There's nothing else. I can't cancel out twice, okay? So once it cancels out, once in the numerator, that's it. Because I know 6, 5, 4, 3, 2, 1 is a part of 15, but that's what makes that 15 factorial, okay? So that means that 6 is going to be what's left over. So now all you have to do is just figure out what is your 20 factorial. So we got our 20 factorial, and then we have our divided by our 6 factorial. Okay. Oh, sorry, not 20 factorial, because we got it all situated. So we got our 20 times 19 times 18 times 17 times 16, right? Divided by our 6 factorial. There we go. And we should get an answer of 2,584. Because we took our 20 times 19 times 18 times 17 times 16 and divided by that 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. And this is our answer, 2,584. All right. Yes, you're so welcome. Thank you. Thank you for sharing the live. Thank you for being here, guys. I know it's an early Sunday morning. Like I said, I had to do something. I was like, let me do something productive. All right. So the reason why we're going through the factorials because you're going to need it, especially when it's down for you to calculate what your permutations and your combinations are. So that's what we're looking at. So when we're talking about permutations, basically the difference of permutations and combinations is one has to deal with order, which is your permutation, and the other one doesn't. So like if you have a list or a combination, so like think about when you're going to go out to eat, and when you look at a menu, there's different combinations. When you go to McDonald's, when you go to any place, when you want to get those combos. But some places they'll have either fries or onion rings as a side order. You can have a baked potato, you can have a salad as a side order. You can have so many different combinations of the meal based off of the menu. So permutation is kind of dealing with order. So I like to think of when there is like a school election. You have all these people that are fighting for certain positions, which is president, vice president, possible treasurer, okay, possible something else, community relations, whatever it is. So there's always like some positions that people are basically going for. Maybe that you want to arrange, like if you look at the shelving of a store, like they want to know how many different combinations can we display the items that will be best for sale. How do I put the best-selling items? One week it'll be the best-selling items, the next week it wouldn't be. But then I have to like, how many times can I arrange to make sure that everyone is getting equal bill? Okay, because that's what we're looking for, as getting as closely as likely of being bought or sold or whatever. We want to see how many combinations can we display that information. Okay, how many combinations and where we can do it. So with that, I'm going to take it to the other side of my book. And let's see if I can do a little bit of shrink. All right, so we're talking about permutations. Okay. Which order or placement? Yeah, I want to say or placement is important. Let's see if you guys can see that. Okay, so permutation. So the key thing is order and placement. Okay, we have to have a certain order. Okay. So in order for us to have like a certain order or placement, so we can say, let's say for my first example, we can talk about so we could say there are 8 students in a race. So if we say 8 students are in a race, we want to know how many different ways can the top can the top 3 finish? Okay, so if there's 8 people in a race, How many different ways can the top 3 finish? So there's got to be a first place, a second place, or a third place. So order is important. So when we look at that, we could do like a whole, what is it? A tree, a factor tree. Or we can basically say it like this. So permutation is listed as the number of people that are in the race. We have our permutation sign. And then how many combinations we're looking at. This is the symbol for permutation. Okay? If we had to do it by hand, this is going to be your formula. So the formula is going to be your permutation dealing with your n comma your r. And it's your n permutation or factorial over your n minus r factorial. You see why we had to do the factorials? Okay, because in order for you to understand the formula, you had to go into the factorials because that's going to tell you your grouping. So if we have 8 students, that's going to be your n, and then the different ways of getting the top 3 finishes, that's going to be your r. So your 8 is going to be your n. And your 3 is going to be your r. So if you ever see something like this, this is not probability. Okay, this is not probability. This is permutation, which is a form of probability. So it's not the probability of you getting an 8 or a 3. Okay, so we're looking at our n, which is 8 factorial, over our 8 minus 3 factorial. Okay. So 8 factorial, that's the same as saying 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But just like order of operations, we want to do what's inside the parenthesis first, because then we can possibly do a little bit of getting rid of. 8 minus 3 will give me 5. So the 5 factorial is a part of the 8 factorial. So if I count down 8, 7, 6, here's my 5 factorial. Because 5 factorial means 5 times 4 times 3 times 2 times 1. And that's exactly the same thing that's happening down here in the denominator. So that means these two things can eliminate. So now all you have to do is focus on the 8 times the 7 times the 6, which gives us 336. So this is the number different ways that you can have 8 students in a race be the top 3 slots. Okay. Okay. Any questions so far? I do. All right. Now, if you want to do this in your graphing calculator, again, you can visit that math button. So remember, your starting number is 8. So we want to type in the 8. We want to go to math. Arrow over to prob, which is short for probability. And then we want to find permutation. Permutation is number 2. Okay, notice they give us our little shorts. So we're saying 8 is my n, we're doing permutation, and we need to find our R, and our R is 3. That's what they gave us. All you have to do is hit enter, and you get 336. And that's exactly what we got by doing it manually. Okay? So, if you want to say, like, how does she do that again? Let me bring it over to the other side because I did put it in with my steps. Zoom in a bit. Okay, so if we're doing permutation, that's this purplish one. All right, so you hit math, hit the left arrow, go to prob, short for probability, hit number 2. So make sure you type in the first number, then you do math, arrow, prob, number 2, and then type in the second number and hit enter. Okay, so these will be like your calculator shortcuts. All right. So if they give us let's say oh wait, let's try this one and go here. Thanks for the likes. So we have example. So we want to know how many ways can you arrange this shows my age here, Blu-ray. What is that? What's a Blu-ray? It's almost like me saying arrange 10 cassette tapes okay, on a shelf. Okay, so we can think of it one of two ways. Okay, so how many ways can you arrange 10 Blu-rays on a shelf? All right, so it's not telling me to kind of like dump it up there. So I know if I put one of those Blu-rays, so we start off with 10 Blu-rays, right? And if I put one Blu-ray on the shelf, now I got 9. If I put another one on the shelf, now I got 8 left. If I put another one on the shelf, I got 7. If I put another one on the shelf, I got 6. Oh, this looks familiar. I got 5. Then another one, 4. Then another one, 3. Feel like DJ Khaled. Then another one, 2. Then another one, 1. And then we don't have any left. What's another way that I could say this? Okay. All right. Yes. So we could say 10 factorial. There you go, Pog. Okay, we could say 10 factorial. So if we want to do 10 factorial, we can do it in a calculator, or you can just put all these numbers being multiplied in your calculator. Okay. So the different types of ways I have, let's see, 3,628,800. And you're thinking, but it's only 10, but seriously. Yep. So you can either have it represented like that, yes, or if you have it, your n is going to be 10, and you know you're going to be dealing with 10. Okay, so you're going to have to put them at a rate of 10, and that will also give you your answer of the 10 factorial. Okay, so you're either going to see it like this, or you're going to see it like this. And I know someone's going to feel really hesitant to say it's 1. No, it's not 1. So it's like you start off with 10, you put it on the shelf. Now you got 9, okay? Then you pick another one, you put it on the shelf. Now you got 8. Then you got 7. Then you got 6, and so forth. Okay. I'm not sure if I blacked out or not, but I keep getting these weird things with TikTok lately. All right. So that's permutation. Okay. Permutation deals with order. So now,
We see you getting after your fitness goals. But what about those money goals?
Yeah. What about those money goals? Last part we have is combination. So combination is similar to what I said earlier about menus. So combination is basically a listing when order is not important. Okay. So like if you want, you can get a cheeseburger. Okay, what do you want with the cheeseburger? Do you want, what kind of cheese do you want? All right. Do you want pickles? Do you want lettuce? Do you want tomatoes? Do you want onions? Do you want fried onions? Do you want raw onions? Do you, do you want a dill pickle, or do you want like, what is it called? Sweet bread or something like that. Like, what do you want? There's so many different things. And I know we have something called Five Guys. And I was trying to show my students that of all the different ways, there was like around roughly like 52 different ways that you can order a hamburger. You can have kid size, you can have vegan, you can have all that. It was like roughly 52 different ways. And we looked at the different combinations and they're like, wow. And I'm like, yeah, that's how come when I go to like say a deli or a diner, it's like the diner, they have like their menus are like this thick. And you're like, what do I want? Because it's so much. It's just sometimes it gets to the point that it's too much. So when it comes to combinations, we're looking at like how many different ways a committee. So let's say a club. I think I should have just wrote this out. So we have a club with 10 members. They want a committee. So if they want a committee of 4 members. So they want like a 4-member committee. Okay. So we want to know how many different committees are there? Okay, are possible. We'll say are possible. Because it's not set in stone until someone actually votes. All right. So how many different committees are possible? Well, we have 10 members. Okay, so order is not important. We want to highlight that. So then here we have 10 members and they want a 4-member committee. So when you do this, even if you mix some of them up, it's not going to be 10, then 9, then 8, then 7, because you're looking at different combinations. So like, you could have Ben and Sally, Ben and Gertie, Ben and Ann, Ben and George. And then you can have some other names that's associated with it. But no matter what, there is going to be a repeat. So you know that Ben, it's not like when we did permutation. If I take one of, let's say, one of those Blu-rays and I put it on the shelf, I didn't put it back in the pile for me to put it back